Hello everyone. Today we'll be talking about linked list. Linked list is a data structure where the data is stored in a sequential order. So, unlike array list, linked list will use random memory instead of continuous memory locations. Linked lists are of three types. One is single linked list, double linked list, and circular linked list. Linked list will contain some nodes. Each node will contain some data and the link to the next node. So in single linked list, each node will contain data and a link to the next node. In double linked list, each node will contain data and the link to the previous node and also the link to the next node. In circular linked list, the last node will contain the link to the first node again. So this is linked list. The first node in a linked list is called as the head node, and each node will contain two properties. One is data and the other one is next. First, let me create three classes. One is node.java and the other one is simply linked list.java. The prerequisite to understand these videos is you must have some basic knowledge of Java syntaxes. Main.java to execute the code. And first let me create node class, public class node. So what I have said you previously, each node will contain two properties. One is data and the other one is next. The data can be of any data type. We can, let us take integer type, and then will contain next. Next is what? Next will be the link to the next node. So it is of type node again. So node next. Let's initialize this node class with a constructor, public node of. It will accept one argument, that is data. Constructor name should be same as the class name. This dot data is equals to data. This dot next will be equals to null, because initially when we create a node there will be no next node, so it will be created, the link will be created as null. This is creating the or designing the node class. Now we will create singly linked list class. So let's create public class singly linked list. So in this class, what are the properties that the linked list class are gonna have? So it will contain a head node which is of type node head. And in this linked list, we are going to perform some operation, that is inserting an element at the end of the linked list and deleting an element by value, and also traversing over the linked list. These are the operations, the basic operations that we're gonna see how to perform. So first let's create a method to insert a node at the end of the linked list. This is not gonna return anything. Public void insert. To insert we should pass in some data. So we are passing in some data. Public void insert. So to insert a node into the linked list, we have to check some conditions. What are the conditions that we're gonna check? First, we have to check whether the linked list is empty or have some elements. If the linked list is empty, we just have to make it the head element or it as the head node. Our new node, we have to make our new node as the head node. So first we need to create a node before inserting. Node, let's name it new node. Node class will accept data. After this, now we have to check the conditions. If we have to check the head is empty or have some elements. If head equals to null, then what we have to do? We have to make the new node as our head node. Head will be equals to new node. We just assigned our new node to the head. If this is not the case, then we have to traverse over the linker list till the end, and when we reach the end we have to make what's the last nodes next will be null now. So the null will be, we are making that null as our new node. That's it. So to traverse we are using a while loop. While let's take one temporary node to traverse over the linker list. It is of type node. Let's name it current. Node current equals to, have to traverse from the beginning to the end, so let's assign it with a head node. We have to traverse until current dot next is not equals to null. When the last nodes next will be null, then that is the last element of the linker list. So when we reach the last element of, until we reach the last element of the linker list, we have to move our current element from one node to the other node. So we will make current equals to current dot next. So in this condition we forgot something. So we have to return. When the insertion is completed, we should return. This is done. So when we reach the end node, that is the last node, we have to insert it now. So the current dot next will be our new node. So current dot next previously will hold a null. Now we are assigning it to new node. This is inserting at the end of the linker list. So let's define one more method to display this. Public void display we will not pass any data to display, because we are just displaying whatever the data which is already in the linker list. We are not going to pass anything to it. So we just have to check the condition. We have to iterate over and we have to check. So we will again define a temporary node current equals to head. We have to traverse from the start to the end. Till the current is not equals to null, we will iterate over. Each time we have iterated, we have to print it. We cannot access the element directly by calling current. Current will call the nodes, some id will be called. I will show it to you. But we have to call or to access the value of a node, we just call it with dot data. System dot out dot println of current dot data. Just have to do this. Okay, when the current is just not equals to null. Okay, it's a it's just a silly mistake. We have to check iterate over the linked list till the end. So while current is not equals to null, we will iterate over and move the current element from this node to the next node. Current equals to current dot next. Before moving, we have to print it. So system.out.println of will print our current element. We cannot directly, if we call current, it will print some node ID something. But so we have to call it with data. Then current will be current dot next. So after this, we have reached the end position and we have printed. We'll just use this is just for the new line. We can use print here, and to display the data properly, we can simply do it like this. So let's test this first. Java C space node.java and then singly linked list dot java and then main dot java. It was compiled successfully. Then we'll run with the main method. Could not find or load class main. Oh, sorry, we didn't created the main class. So first we have to define the main class. Public class main string of args, and inside this we need to create the linked list first. So singly linked list is equals, we can also implement linked list using queue, but we are implementing using list here. After this, we have to call the method we have created in the singly linked list class using this object. List dot insert of, we can insert some data here. So make it 20, let it be 30, let it be 40. And then we have to call list.display to see the inserted elements of the linked list. Compiled successfully. See, these are the elements that are present in the linked list. So now we have to see one more operation that we have to perform, which is deletion of a particular element in the linked list. So let's go to the single linked list class and create one more method, public void delete. This method will also not return anything because we'll just delete, we will not return anything. And then to delete an element, we will just change the link. Whatever the operations that are going to perform on the linked list, we are not going to delete or actually do anything. We will just remove the link to that object, or if we will just change the link from that to another one. That's it. So to change the linked list, what are the logic that we are gonna do to delete is, for example, if I am in a current position, I will change the previous ones next to my previous ones next will be linked to my current element. Current element at right now. So what I will do is I will change that next to the next elements next. So see that here, you can understand it clearly. So let's create two temporary nodes here. Node current equals to head, and also node, let's define which is previous equals to for example, if the current element is null and there is no previous element, so it will be null. I'll just make it null. And now we have to check some conditions as in the insertion. So what are the conditions that we're going to check is, we have to check if the element we are going to delete is the first element. We also have to make sure the linked list is not empty. So what we're gonna do is, if current not equals to null, and we will also check, we will pass in, to delete an element we have to pass in some key, int key. So we will check if the current dot data is equals to key. If it is equals to key, then the key that we are searching is in the head position. We will just make the next node as the head. So head equals to current dot next. If this condition is true, then we will return. If this is not true, then we have to traverse over the linked list until we find the key. When we find the key, we have to delete that. That means we have to unlink to that particular node. So what we will do, we will traverse while current, we have to always check the current is not null, and we have to check current dot data is equals to key. Then what we will do? We will move current to current dot next. Before this, what we have to make sure is we have to make previous as the current element. So once we get out of this loop, what's the conditions that will make us get out of this loop? So whether the current will be equals to null or the current dot data is we have to iterate this loop until it's not equals to whether it will be equals to key. First we will check this condition. If current equals to null, that means if the current is equals to null, then we will just return. We don't have to do anything. If this is not the case, then this might be the case. That means we have found the key. Then what we will do is we will unlink this. We will make the next of the previous element as the next node. That means current dot next. Let's see if this works. So we will go into the main class and let's see list dot delete of 30. Let's delete 30 and then we will again display. Let's test this one. So see 30 was deleted. This is how this works. Thank you so much for watching.